So I started on a quest to upgrade my network to 25 gig because I discovered that 25 gig is basically plug and play, even for Windows systems. You don't have to do anything. You just put a NIC in and it works. And so I ended up upgrading everything to 100 gigabit because that's what you do, right? So in upgrading to 100 gigabit, it occurred to me, we haven't talked about OCP3 very much. I mean, sure, it's been in my server reviews. I've done, server reviews on servers like this Super Micro chassis, for example. This is their Cloud 2U, as they call it. It's got a more complicated model, down here. But this is a 2-socket, 4th or 5th generation Xeon Scalable. It actually has 2 OCP3 slots. OCP3, 16 PCIe lanes, up to PCI Express Gen 5. And I've got an LR Link OCP3 dual 100 gig Ethernet adapter here we're going to take a look at. Wait, LR Link, I've never heard of that. Intel E810 chipset put together by LR Link. LR Link sent me this, but I want to talk about the network layout and the 100 gigabit network upgrade. This is it. It's a giant copper heatsink where most of the weight comes from. And then we've got 2 100 gig physical interfaces, some debug header, pogo pins, and the serial number and all the other stuff on the bottom. And then you've got the 2 100 gig QSFP slots, or ports, I guess. 100 gig, dual 100 gig. So this is technically a 200 gig Ethernet card. If you're not familiar with this sort of stuff, let me show you. Now, AOC and other companies make patch cables where you just buy the entire cable. And so I've got the large, copper to fiber bits and then a nice copper cable. Single mode, multi-mode, yellow or aqua colored. There's a Wikipedia page you can read about the different kinds of fiber optics. If you're still rocking the old orange fiber optics, I'm sorry, that's from the dawn of time. Technically, even the aqua stuff is, the aqua stuff has its place. It's nice. You could also have things like this. This is a color chip 100 gig transceiver. So this is, you've got a pair of copper lines, transmit and receive. These sometimes are designed for long haul. Sometimes they're designed for short haul. If you use a long haul transceiver in a short haul thing, the laser will actually burn out the receiver on the other end because the laser is designed to produce enough light to send it, 10 kilometers or whatever before you need a repeater. So these are not foolproof. In fact, the 25 gig or 100 gig interface stuff is not foolproof because the forward error correction, FEC, the standards for that vary a little bit from 25 gig and 100 gig. 100 gig is also not new. This is a Mellanox ConnectX 5. I think that was originally manufactured in 2018, 2019. This is pre-NVIDIA. NVIDIA bought Mellanox. And this is old. It's got some interesting technologies in it. I think this particular card can act as Ethernet or InfiniBand. InfiniBand is a Mellanox technology that has a lot of advantages over Ethernet, especially when we were talking about latency. And that was really handy when you were building clusters of computers where you wanted to minimize the communication delay between machines. Intel went a different direction. OmniPath, which has spun out of Intel into Cornelis Networks. I've taken a look at OmniPath stuff in the past. But Ethernet is the new hotness, and this is the E810. But this is the first step on the trajectory toward Ultra Ethernet. The old stuff, Ultra Ethernet, was not even a glint in the designer's eye. Ultra Ethernet, it wouldn't be terribly inaccurate to say that that's AKA Infinity Fabric. AMD's opened up a lot of really interesting stuff with Infinity Fabric that just got rolled right in to Ultra Ethernet. Wild times. Very wild times. E810, though, is a 100 gig tried and true Ethernet adapter. Now, they do add stuff to the Ethernet adapter because when you're moving at 100 gig, you can't rely on the CPU to do all the work. Things like iSCSI, you want to offload iSCSI to that. RDMA, you want to offload RDMA to that. And this is where Broadcom, in a lot of ways, got their hooks in everybody because you can't live without that hardware acceleration once you get it. Intel, for their part, was figuring that they were going to be able to use on-chip accelerators like QAT to really take it up a notch with the E810 or with the Intel series networking. But the E810 is a more, let's call it a balanced approach because a lot of the hardware for doing that kind of acceleration is right on the NIC, whereas previous generation NICs, maybe not so much. And the E810 is also available in 25 gig configurations, but dual 100 gig. You can also break out a 100 gig connection. You can get a special cable that will split the 100 gig connection into 4 25 gig connections. You may have seen on this channel adapters that have 2 25 gig connections. You can combine those a lot. It depends on the switch. It depends on what's connected to. You can combine the 2 25 gig connections into one 50 gig connection. This is a Mellanox. This is an even older ConnectX-4. This is the OCP2 interface. So we go from this in OCP2 to this in OCP3. And testing it out, we're going to be using our Supermicro cloud server because it's PCI Express Gen 5. That means just one of our Kioxia CM7 SSDs can manage 15 gigabytes per second. 100 gig Ethernet is going to top out just over 10 gigabytes per second. So yeah, just one of those CM7 disks will saturate our 100 gig Ethernet, at least one channel of it. Dual channel, not so much. But I've got 8 of them in this chassis. This chassis is a little weird because it's 3.5-inch bays, but you can mix PCIe Gen 5 storage and SATA or SAS storage. SAS, you need to add a controller, or you need to add a tri-mode controller, Broadcom, and be off to the races. The other thing that's really neat about this chassis is when you're doing really high speed, really low latency stuff, the PCIe slots will actually let you use cables to configure if you want 16 lanes from one CPU socket or 8 lanes from each CPU socket for a total of 16. Yeah, there are PCIe cards, newer versions of NICs like this, where the NIC actually has 2 interfaces for the 2 sockets, because the cross-socket latency adds too much overhead. So if you're doing operations on this socket, instead of shuttling it across to the other socket and then sending it out that socket's PCIe lanes, we're at a point in time where the design and architecture of those systems is so crazy that that's too slow. It would be better to just provide a direct path from each socket to each physical interface. That's where we are now in the bleeding edge. This stuff is pedestrian. Like, I say that because you should run out and buy 25 and 100 gig stuff, because it basically is plug and play at this point. I mean, if Windows out of the box with 1500 byte packet sizes and the speed of CPUs that we have today can manage 3 gigabytes per second on a relatively unoptimized SMB share, even before we get to talking about RDMA, that is pretty darn good. If you're coming from a Windows file server and you have a 100 gig adapter in your network card, RDMA comes into play. RDMA is remote direct memory access. When you have that level of technology, then you're able to do memory copies over the wire. And then you really can move at 10 gigabytes per second from a Windows file server to something else. This is partly because Microsoft's dogfooding their own technologies, things like ReFS, and looking at the overhead and the dysfunction of that. And Microsoft has dramatically improved those technologies over the last several years. They're really trying in earnest to become a competitor to VMware in those aspects of the technology. Hyper-V, in terms of like the actual virtualization part, has been a solid VMware competitor for a long time, but with Broadcom making certain licensing decisions that nobody likes, Hyper-V has got to shore up some other stuff that it needs to have shored up, especially around hyperconverged storage and this sort of stuff, which is why I have this. Anyway, for my setup here, I've decided to deploy 5200 series Dell switches. This is Open Compute. This is another sort of secret learning that I've sort of discovered. And that is, you generally want to buy the compute and networking gear that Open Compute is buying for themselves. Open Compute you can think of as a consortium of Meta/Facebook, Amazon, Google, Microsoft to a certain extent. And Open Compute really defines to the nth degree exactly what they want to buy. They want to avoid vendor lock-in. And so Dell 5200 series and 5100 series 25 and 100 gigabit switches, those are 4 or 5 years old at this point, but you can get them on eBay. Their price on eBay did this. And the reason that it bottomed out is because you couldn't get the Dell operating system for those switches, but they're Broadcom chipsets. And so there's an open source operating system. We did a how-to on that years ago. And it's not great. It's not perfect, but it'll get the job done, mostly. There's some caveats there, but it's not terrible. And because of that, nobody wanted to pay for Dell's operating system. So mostly Dell makes it pretty easy for you to get a perpetual license for your 5200 series switches, even if they're the Oni variety, which is the Open Compute version. because who wants to pay thousands of dollars a year for the operating system for your 100 gigabit network switch? 100 gigabit is basically old hat at this point. We're moving into 2.4 and 800 gigabit, 1.6 terabit. 1.6 terabit really is right around the corner. So they're not really super affordable at this point, but I have some 5212s and 5248s and 5148s. Not bad for this use case. They're a mix of 25 and 100 gig ports. The 100 gig ports can be broken down into 4 25 gig ports, of course, but you get 3 100 gig ports on the 5212. Now the 5212 technically is meant to be used in pairs. So like you have a 1U 5212, it's actually 2 5212s in a 1U chassis, and that is for high availability reasons. So you get 3 100 gig ports on each side and 12 25 gig ports on each side. I'm using it in a not redundant way because my stuff's not that important. I mean, okay, maybe the core switch is redundant, but the non-core switch, not redundant. And so in our test lab, I just have half of a 5212 or one 5212 that has 300 gig ports and 325 gig ports. And that makes the setup like this fantastic. So if I want to load large language models on this and have a very high-speed, low-latency storage machine to experiment on, whether with Windows Server 2025 or the experimental RDMA-capable SMB server that's floating around out there on the internet, there's some commercial projects. Also, I'm exploring Xener Array. Does anybody know anything about the Xener product? It looks pretty good on paper, and on a system like this, where it's Emerald Rapids and it's insanely fast single-thread clock speed, and I've got 8 of these insanely fast Kioxia CM7 drives. It seems like the Xener is a really good solution. It's not as good as ZFS, but it has way less overhead than ZFS. It's not as good as ZFS in terms of data integrity, but few things are as good as ZFS in terms of data integrity. But is it good enough in terms of data integrity? Well, that's a question I'm exploring, but I'm also interested in what your experiences are with the product. If you've used the product in your enterprise, if you found anything that's I'm exploring it. So I want to live vicariously through your experiences, and this is one of the chassis on which we're doing it. Now at 100 gigabit. With a modern E810, brand new, 100 gigabit network interface. Well, 200 gig technically, because I'm going to use both of them. Plugging this in and interfacing this could not be easier. At the rear, this chassis has 2 of these OCP3 slots. Like I said, there's 16 lanes. You just slide the module in and you thumb screw and boom, that's it. There's one from each CPU socket. Now, you can use a direct attach cable for crossover, or if you need to push the signal a little bit further, you can use a color chip transceiver like this. Somebody say 100 gigabit color chip? That's a lot of transceivers. Not really. It's just 10 connections. And that's basically it. Now this is good to go. This is going to show up in LSPCI as an Intel E810. The Linux kernel has great support for that out of the box, including accelerated iSCSI with you got to jump through like 1 or 2 really minor hoops. But yeah, this is insanely fast, and that's all we need. So let's go get this set up in the lab. And blinky green light. Woo! The EFI support is pretty good for this network card. You can configure to pick up an IP via DHCP, or you can set it manually. The reason this is handy is because the network EFI has options that you can control, like actually from the BIOS. Yeah, so it shows that it's connected. And this is great. It's configured with an EFI. The E810C has a built-in EFI module, which will let you do network booting, PXE booting. Technically, Intel's wanting to move away from legacy iSCSI. There is a legacy iSCSI support kind of thing. Sometimes you see iSCSI options for booting directly off of an iSCSI volume, but this is a pretty reasonable level of EFI support for these NICs. There's also basic diagnostics in where you can blink the LEDs for a period of time so that you can find which NIC it is physically. Another really nice option is that the device level configuration, you can configure the different port options. So 2x by 1 by 100 gig, or the particular port can be 2 by 50 or 4 by 25, or 2 by 2 by 25 or 2 by 4 by 10, or just 1x 100. So each individual port can be a single 100 gig connection as opposed to a automatically in hardware redundant 100 gig connection is usually how people will use that. Virtualization mode, you have SRIOV and scalable SRIOV, so it supports both of those things. You can also enable transmit balancing, so this is pretty cool. It does it in hardware across physical and virtual functions so that you don't have, a noisy neighbor type situation on a virtual function that's starving out all of the other virtual functions for the virtual NICs that are created by SRIOV. This is actually pretty handy. It's nice to see this accessible in the BIOS, because sometimes fiddling with this stuff with ETH tool on Linux, for example, is annoying. Forward error correction is more of a problem than people realize. 25, 50, 100 gig is just not plug and play. You have to configure things. That's a Ubiquiti Dream Machine, the Enterprise XG. It's 24 10 gig ports and 2 25 gig ports. You'd think those 2 25 gig ports would be the perfect leaf into this network. You'd be wrong. The firmware that makes it work is less than 2 weeks old at the time that I'm shooting this, because they didn't have forward error correction figured out. And there was a disconnect between what you could do in the GUI and what you could do at the command line. It's just Ubiquiti things, but that's what happens when you mix brands. Oh, and also the brand of the little transceiver that converts copper into fiber, that also matters a lot. Ubiquiti doesn't intentionally care about the brand, but Dell does. You have to allow unsupported transceivers. So it's not totally plug and play. You can't just use random crap on a 25 or 100 gig network. You have to make sure that everything is actually compatible, because it's not like gigabit or 2.5 gigabit or even 10 gigabit where everything is so standardized it just works. That was a headache. Yeah, so there we are. Full feature set with our Intel E810 on this tiny little package. No overheating. There's adequate airflow for my chassis. The overheating is really going to be a function of the chassis. You might have to tweak your fan speed or something like that if you're DIYing a build here. But yeah, the LR Link dual 100 gig was perfectly reasonable E810 dual 100 gig experience, which worked great with both my Dell 5212 as well as my 5148 and 5248. Different floors for different switches or something. I don't know. The 100 gig backbone is nice. It's very, very nice. The Windows support for the E810 is also quite a bit better than an older Mellanox card. NVIDIA is really, really concerned with getting the latest and greatest out the door, and I don't think a 4-year-old Mellanox Connect X5 is really going to get all that much more support, especially when we're talking about the Windows platform. A little different story on the Linux platform. Yes, I get it. And Mellanox and NVIDIA's solution is very good, but I think I'd rather have a new Intel E810 versus an older CX4 or CX5. Especially if I'm looking to use the Kioxia CM7 SSDs to their full potential. Those are Gen 5. The other part of the equation, too, is it's not just throughput. I mean, 10 gigabytes per second, okay, it's also very low latency. Latency is about IOPS, is about everything else, and that's one of the places where ZFS will fall a little short. You got to map your record size into what the VM is using, and then if you have a very small record size, it's going to have a lot of CPU overhead. That's where all those cores in both of those sockets with all that fast DDR5 memory can come in handy on that platform. You know, I've seen people deploy the Supermicro server as an application firewall, like a filtering application firewall. Now, granted, if you've got a connection that is 100 gigabit and you're pushing that much traffic and you need to monitor, wow, that's something. But for doing the intrusion detection and intrusion analysis, having that much CPU overhead and that much fast storage and that much fast networking means that the translation from the unwashed masses outside to the protected inner nougat of delicious networkiness is a little bit less latency overhead, because you got all that computational horsepower doing all of that analysis. So even dual 25 gig connections, you might run something that powerful just to be able to do that level of analysis. It's pretty wild. Beyond that, you get into specialty security appliances, and then the appliance has, ASICs or something to be able to do that kind of deep traffic analysis quickly. Some of these appliances also do SSL stripping, which means they strip off the real SSL and they apply an internally trusted SSL so that they can do traffic inspection of encrypted connections. That's a whole other conversation. Intel E810 LR Link. Check them out. I'm Wendell, this is Level 1. I'm signing out. You can find me in the Level 1 forums.